Assalamu alaikum students, this is Majid Tahir. We are doing computer science lesson number 2. Let's start. That computers have to convert everything into binary. So let's see how images and text and everything is converted into binary. We'll first see conversion of text into binary. When text has to be stored, it is necessary that computer stores this in binary format. So there is a coding schemes that we use. We use two coding schemes, ASCII codes and UNICODE. When we convert a code into binary, we call it a character code. First, we'll see ASCII codes. ASCII stands for American Standard Code for Information Interchange. It's used for the longest time. ASCII is an internationally agreed standard coding scheme. It uses 7-bit code. The full table shows 27 or 128 different codes available for 7-bit code. Let's see. Now, computers has to store text document both on disk and memory using ASCII codes. ASCII codes are normally used for English language. For example, if you use Notepad to create a text file, for example, Force code in 7 years ago, this text has to be converted into binary. Every character on the screen takes exactly 1 byte. So it's going to be 30-byte long text converted into binary. Notepad use 1 byte of memory per character, including 1 byte for space. You should not try to remember the codes for ASCII code. There are certain aspects of the coding scheme that needs to be remembered. Now let's see. These are the ASCII codes given. Every ASCII code has equivalent decimal number, a hexadecimal number, and a binary number. We don't need to learn all the codes, but things that need to be understood are these. ASCII has some special features that make coding scheme easy to use. The first is that codes for numbers and letters are always in a sequence. In each case, for example, if 1 is added to the code of 7, you will get a code of 8. Same way, if 1 is added to the code of A, you will get code of B, and then code of C, and so on. The second is codes for the uppercase letters are different from the codes of lowercase letters in the value of bit 6. For example, this is a code given for letter A, small a, and this is capital A. Hexadecimal for lowercase a is 61, uppercase a is 41, this is 61, and this is 41. Now you see this 1, 2, 4, 8, 16, 32, and 64. These are 7 bits. The code differs for uppercase and lowercase in only 6th bit. Wherever uppercase has 0, lowercase will have 1 over here. Same way, if you see the code for lowercase y, which is hexadecimal 79, codes of uppercase y, which is 59, same way they differ in the bit 6. Okay, another coding scheme is called UNICODE. Since ASCII code has number of disadvantages and is unsuitable for some purposes, different methods for coding have been developed over the years. One coding scheme is called UNICODE. UNICODE allows characters in code form to represent all languages, thus supporting many operating systems, search engines, browsers. So this is overlap with ASCII codes. ASCII codes that are already used for English language are embedded in UNICODE. So it works by providing a unique number for every character. This creates a consistent encoding, representation, and handling of text. Basically, UNICODE is like a universal alphabet that covers the majority of different languages across the world. UNICODE has its own terminology. For example, a character code in UNICODE is called a code point. ASCII uses 1 byte to represent 1 character, whereas UNICODE support up to 4 bytes per character. On your screen, you can see Urdu alphabets and Unicode characters underneath that. So for Alif, you have FE8D. For Bay, you have FE8F, and so on. This is it for today's topic. Thank you so much for paying attention, and like the video and share it with your friends.